Let's solve this equation from the review sheet. It's one of our more unusual equations. It has variables with rational exponents. So when we're confronted with what we've kind of jokingly called a weird equation, let's see what we can do with a substitution that might help us. And one thing we need to recognize: if you square x to the 1/4 power, when you raise a power to a power, you multiply the exponents. So x to the 1/4 power squared would give us x to the 2/4. 2 times 1/4 is 2/4, which is x to the 1/2. So the square of this variable is equal to this variable. And that's typically a clue that we want to use a substitution. And when we make the substitution, we will actually end up with a quadratic equation we can solve. So let's make the substitution of letting y equal x to the 1/4. So that would mean this term would become minus 4y. And since the square of x to the 1/4 is x to the 1/2, then this term could be replaced by y squared. So once again, I have what? This variable is the square of that variable, and that's what we have here. This variable is the square of that variable. But now this looks like just a normal, run-of-the-mill quadratic equation. So we can go ahead and solve it using our methods that we have available to us. Quadratic formula. But in this instance, I'm going to take a quick look at this problem to see if it's factorable. If the coefficient of the squared term is 1, I'm at least going to pause and look at the equation to see if the polynomial might be factorable. Y times y will make y squared. 2 times 2 would make a 4, or 1 times 4. I'm going to try the 2 times 2. And if the signs were both subtractions, in the binomials, that minus 2 times minus 2 would give me plus 4 under the L of FOIL, and the O of FOIL will give me minus 2y. The I of FOIL will give me minus 2y. Those would combine to minus 4y. So that trinomial was factorable. So that gives us the solutions that y equals 2. And it's identical solution, isn't it? Both of these situations, the solution would be y equals 2. Well, now I can substitute back. Y was holding the place of x to the 1/4 in order to make the equation less complicated, less intimidating. So now let's substitute back. So x to the 1/4 will equal 2. And now I can get rid of that rational exponent by raising this side of the equation to the 4th power. Remember, x to the 1/4 is the same as the 4th root of x. So by raising both sides to the 4th power, I'm doing the same thing that I would have done if I would have recognized that as being a radical expression. That's how we solve radical equations. Isolate the radical expression, raise to the appropriate power to undo the root. So I'm doing the same thing here. And again, 1/4 times 4 is 4/4, which is 1. That gives me x to the 1st. And 2 to the 4th power, that's what? 2 times 2 is 4, times 2 is 8, times 2 is 16. And the same thing would happen here. So we could have approached that problem either just leaving it as a rational exponent, or we could have converted it to a radical expression. So since this equation really at heart is equivalent to a radical equation, we probably should check our answer to make sure it works. So let's take 16. Well, 16 to the 1/2 power, that would be the square root. So the square root of 16 would be 4. the 16 to the 1/4 power would be the fourth root of 16. The fourth root of 16 would be 2. And does that expression now equal 0? Yes, it does. 4 minus 8, right, plus 4 is 0. So our solution is a good solution.